So, for the last few years, AI has been this thing that lives on our screens, right? We've got chatbots, we've got image generators, but a whole new wave is coming. And this one is about to step out of the digital world and right into our physical one.
And that really is the question, isn't it? What happens when that intelligence is no longer trapped behind a piece of glass? Because when an AI that can learn and reason is no longer just confined to a server somewhere, well, that's when everything starts to change.
Yep, it gets a body. The next giant leap for artificial intelligence isn't just about writing smarter code. It's about giving that code hands and legs and the power to actually move around and interact with the real world.
What we're witnessing here is this incredible fusion of two massive fields. So you shouldn't think of this as just an upgrade to the robots or the AI we already have. No, this is more like the birth of a brand new category of technology, where these brilliant AI minds are finally meeting really capable machine bodies.
The technical term for all this is embodied AI, or EAI for short. And let's be super clear, this isn't some far-off sci-fi idea anymore. These are real systems being built as we speak, designed to see, to learn, and to act right here in our world.
This Venn diagram really breaks it down perfectly. So on one side, you've got your classical robotics. That's the brawn, right? The powerful, precise machines you see on assembly lines. On the other side, you have agentic AI. That's the brains, like the large language models we've all been playing with. Embodied AI is what happens right there in the middle, in that powerful sweet spot where the brawn finally gets a reasoning brain.
You remember that ChatGPT moment, right? That feeling when, almost overnight, AI could suddenly do things we never thought possible. Well, the big takeaway here is that a lot of experts believe robotics is on the cusp of its very own ChatGPT moment. A similar explosion in capability that's going to completely change what physical machines can do.
And you know, this isn't just some R&D project tucked away in a lab. Nope. There is a full-blown race happening right now to build the first generation of humanoid robots that are actually commercially viable, specifically designed for industrial work. And really, when you cut through all the hype, all the slick demo videos, it all boils down to this one question. Who is actually going to be operational? Who's going to be ready to clock in and do the work?
So get this, 2026, you're going to want to circle that year on your calendar. This isn't some vague, futuristic prediction. It's the target timeline the entire industry is sprinting towards. It's the year they need to prove these humanoids are more than just cool demos, that they're ready for real, tough, sustained work. The pressure is on.
Okay, so let's look at the key players in this race. First up, you've got Tesla's Optimus, and its huge advantage is that Tesla can test it in its own factories. Then you have the legend, Atlas from Boston Dynamics. You know, the one doing all the parkour? Well, now it's being prepped for serious work in Hyundai factories. And the new contender that everyone's talking about is Figure 02, which has been making some incredibly smart moves by partnering with heavyweights like OpenAI and Microsoft. Everyone's got a different playbook, which makes this race just fascinating to watch.
Okay, so wait a minute. How did this happen? How are these robots suddenly getting so smart, so capable? What is the technological leap that's making all of this possible, like right now?
Well, the secret sauce, it turns out, is a couple of new kinds of AI brains. First, you have large multimodal models, or LLMs. The key word there is multimodal. They don't just understand text, they process images, sound, and sensor data all at once. Then you've got vision language action models, or VLAs, and they do exactly what their name says. They take all that understanding and translate it into physical action. It sees the cup, understands you want it, and picks it up.
Now, deep inside these new AI brains is something truly mind-bending called a world model. Honestly, the best way to think about it is as the robot's own imagination. It isn't just reacting to what it sees, it's constantly running an internal simulation of reality. This allows it to predict what might happen next. You know, if I push this block here, it's going to fall over there. That ability to simulate consequences, that is the absolute game changer for intelligent action. And this diagram shows you how that software brain actually connects to the physical body. It all starts in the onboard processors. That's the thinking part. That thought then flows out to the actuators, which are basically the robot's muscles, to create movement. But at the exact same time, a constant stream of information is flowing back in from all the sensors, the eyes, the ears, the touch. It's this continuous, super fast feedback loop of perceive, think, act, repeat that makes embodied AI work.
But of course, as these incredibly capable machines start walking around in our world, they bring a whole new set of challenges with them. A whole new set of risks that, honestly, we're just beginning to figure out. We're going to need new rules for these new robots.
When you break down the risks, they basically fall into 4 big buckets. First, there's the physical risk. I mean, what happens if someone with bad intentions hacks or jailbreaks one of these things? Second, there's informational risk. A walking, talking sensor platform could be used for mass surveillance. Third, the economic risk. The very real possibility of massive job displacement is something we have to talk about. And finally, there's the social piece, the disruption that's bound to happen as we all learn to live and work alongside machines that are so much more than just tools.
And here's the really worrying part. Despite all these very clear, very real dangers, the policies we need to manage them, they just don't exist yet. One expert called it an alarming policy vacuum. The technology is just moving so much faster than our ability to regulate it safely.
So what do we do about it? Well, experts are laying out a pretty clear roadmap. Step 1, we've got to invest in research specifically on EAI safety. Step 2 is getting the industry to create its own dynamic standards. Step 3, and this is a big one, is figuring out legal liability. Who's at fault when an autonomous robot messes up? One fascinating idea is to require them to have black boxes, just like airplanes. And finally, all of this needs to be supported by real policies to help people manage the economic and social changes that are definitely coming.
But you know, even as we're scrambling to write the rules for today's robots made of silicon and steel, some researchers are already looking way down the road, to a frontier that moves beyond metal entirely.
And they're exploring this wild concept of biohybrid robots. We are talking about building systems that aren't just machines anymore, but a genuine fusion of engineered parts and actual living biological tissue.
The potential here is, it's just staggering to think about. We're talking about systems that could heal themselves, maybe even replicate themselves. Imagine robots with integrated brain tissue that don't just run code, but actually learn and adapt organically. Or imagine prosthetics that aren't just attached to a person, but are truly biologically fused with them. It's the far-out future, for sure, but this is where the path eventually leads.
And that's what it all comes down to, doesn't it? This final, profound question. This coming wave of AI robots is going to force us to rethink our economies, our societies, our laws. But as we start blurring the line between machine and organism, as we create machines that are more and more alive, we have to face a much deeper question. What does it even mean to be human anymore?